Hey everyone, so in this video or lecture, we are going to show you how to compute the determinant of a 3 by 3 matrix. This is a very important topic at this level. So the one thing you need, a few things you need to know, right? And that we will use to compute this determinant are obviously what a matrix is. You need to know what a determinant is, but then also how to compute the determinant of a 2 by 2 matrix, what a cofactor is, what a minor is, right? These are of a matrix. So these are important topics and we have already put videos on them. So just go check them out if you're not familiar or want to revise those topics. And then we'll use those, those topics or those concepts to compute the determinant of a 3 by 3 matrix. So this is the matrix that we're going to start with, right? This is what we want to compute the determinant of, and instead of using the typical square brackets, it's a determinant, so I'm using determinant notation. And this minus 3 is the answer, so I've already given you the answer. You know the determinant of this is this. Now, how do we go from this matrix to this determinant, right? So let's start with a simple approach. Take the first row of the matrix, right? And we're going to use that row and its cofactors, right, to compute the determinant. So you take the first element, so that's 1, and you multiply it by the cofactor. Now, if you do not remember what the cofactor is, the cofactor you take out. So the cofactor of a11, which is this element, is you remove that row and that column. You end up with a sub matrix. Take the determinant of that, and then you multiply that determinant. So that's this term that you see here. You multiply that determinant by minus 1 to the power of ij. In this case, it's element 1, 1, so 1 plus 1. So it's 1 times the cofactor. So a11 times the cofactor 1, 1, right? Plus, right, second term times the cofactor of that. So 2. So you take out the first row, first column, you end up with this sub matrix. Take the determinant of that and multiply it by minus 1 to the power of 1 plus 2, because this is a12, and you multiply that by that. So a12 times the cofactor of 1, 2, right? And now you can guess, you say plus the third term, right, in that row, right, times the cofactor. So this is the submatrix, this is the cofactor of the submatrix. You find the determinant of the submatrix and multiply it by minus 1 to the power of, and because this is 1, 3 to the power of 1 plus 3, right? And what you get by evaluating this expression is the determinant of the 3 by 3 matrix, right? So just to revise, what do you do to find the determinant? You take the first row of the matrix and you take the first element a11, you multiply that by the cofactor of 1, 1. You add to that a12 times the cofactor of 1, 2 plus a13 times the cofactor of 1, 3, and you're done, right? Simple. And we all know how to compute the determinant of a 2 by 2 matrix. So for example, in this case, the determinant is just this minus this. It's a11 times a22 minus a12 times a21. So 4 times 3 is 12, minus 1 times minus 1 is minus 1. So it's 12 minus minus 1, which means 12 plus 1, 13, and so on, right? And you've got your determinant. So you've already seen the steps, and you can just go back and play the video again to revise that. But what you end up with is this times the determinant of this, and I've absorbed the sign of the cofactor. So minus 1 to the power of whatever, I've absorbed it here, right? So minus 1 to the power of 1 plus 1 is 1. So 1 times 1. Here it's minus 1 to the power of 1 plus 2. So minus 1 to the power of 3 is minus 1. So this has become minus 2. And this again, minus 1 to the power of 3 plus 1 is minus 1 to the power of 4, which is 1. So plus 1 times. So it's 1 times this minus 2 times this plus 1 times this. And for a 3 by 3 matrix, actually if you choose the first row, you don't even need to worry about the cofactors. You can just use the minors. Basically say 1 times the minor term, so this, the determinant of this, minus this term times the minor of that, so this plus this times the minor of this. And now I've just evaluated the determinants. The determinant of this is 2 minus 4 is minus 2. The determinant of this is 6 plus 1 is 7, and it's 1 times 30. right? And what you end up with is minus 3. So that hopefully you've understood, and if not, just go and play it again and you will understand this. And so generally what you do is, to find the determinant of this matrix, you take the standard, or the simplest way to do it is you just take a11 times the cofactor of that plus a12 times the cofactor of that plus a13 times the cofactor of that, and you end up with the determinant. So those are the steps I'm showing you here, right? You pick the first row, find the product of the elements with its corresponding cofactor, and because it's the first row, it's a1j times c1j, right? The column's changing but the row is 1, and you sum and add them up. So now the interesting question is, we're doing it with just the first row. What if we do it with a different row, or can we do it with a column? And the answer is yes. Now just a pointer, if you're doing this for an exam or you're trying to do something where you're getting confused, just stick to this approach, right? Just start with the first row and use this approach or this formula and you will get the determinant right. But just to, for completeness, to kind of give you a picture of how, there are other ways to do this, you can pick any row or any column and follow the same principle. So in this case, it's the same matrix, but I'm choosing this column, the second column. So I take the first term, so this is A1, 2, and you want the cofactor of that. So that's 3, 1, minus 1, 2, the determinant of that is 7. So this is the minor here. Take the second term, so now the minor of that is 1, 1, minus 1, 2, determinant of that is 3. And you have the third term, 4, so it's 1, 1, 3, 1, that's the submatrix, the determinant of that is minus 2, right? 1 times 1 is 1, 3 times 1 is 3, 1 minus 3 is minus 2. And you take the element and multiply it by the cofactor. Now in this case, that's where you have to remember cofactor, because this is element 1, 2. So it's minus 1 to the power of 1 plus 2, so 7 times minus 1 is minus 7. Times 2 plus this is 2, 2. So as you can imagine, the sign is positive, right? 2 plus 2 is 4. So it's 1 times 3. And in this case, again, this is 3, 2, right? So it's, the element, the sum of the indices of the element is 5. So the sign is negative, right? So it's minus 4 times minus 2. And you end up with minus 3. So instead of using the first row, you can use the second row, you can use the third row, you can use a column. In this case, we have used the second column. So a more general way of looking at this, to find the determinant, you can take any row. In this case, this is the first row, or you can take, say, the third row, or you can take the column. So this is the first column, A12, A22, A23. So this is the second column, which is what we have seen before, and you can get the determinant by multiplying the element with the cofactor. It's as simple as that, right? And so I've just generalized those steps I've shown you, where in the first case I'd said pick a row. In this case, you can pick any row or column, and then you follow the same steps. Find the product of the elements with the cofactor and then add them up. Okay? So let's do another example, right? We want to make sure you're clear with this. So this is the matrix. I'm going to keep it simple. Start with the first row. So what you need is 1 times, the cofactor, which is obtained by the determinant of that term, times, and it's positive because it's just 1, minus 0 times the determinant of this term, plus 1 times the determinant of this term, right? And what you get is that, right? So very simple, right? And because you've just stuck to the first row, the signs are very simple. There's no question, there's no doubt. You've just started with plus, minus, and plus, and you're done. Okay. Now, just an illustration or an example of why not choose the first row. And like I said, if it's confusing, just stick to the first row, but why not? So in this particular example, I solve it first by using the first row, right? So I say, okay, the determinant is 1 times, the determinant of this, minus 0 times the determinant of this, plus 1 times the determinant of this. Now this is 0, so I don't need to compute this, but I end up having to compute two determinants, right? So I ended up with, and the determinant of this is 1 times 1, determinant of this is minus 1 times 1 and it's minus, so it's 1. So it's 1 plus 1 is 2. So I have to evaluate this term and this term. But actually if I pick this column, right, this is 0, so I don't need to evaluate the first one. This is 0, I don't need to evaluate that. So all I end up doing is saying 1 times the determinant of this, right, the cofactor of that is 1, 1, minus 1, 1 times the determinant of that. So I just need to pick this one term, compute the determinant, and I've got the answer, right? So the reason why we show you why not necessarily you can always use the first row is, in certain cases, if you're really quick at doing this, you have a lot of practice, it's a competitive exam, for example, and you want a quick answer, just pick the right row, and you can save yourself a lot of time. So hopefully this is really clear. We've shown you 3 examples fairly clearly, and we've shown you using row and column. Just if you have any doubts, just please revisit, just rewatch the video. And what you can also do is go take a quick test on TeachYaar.com, because again we have posted some other cases there, and that should again give you some more practice. So to take the test, you can scan this QR code, or you can just go to this link, and we have dropped this link in the comments and the description section. So go and try that, and the more times you do it, you will get better at computing the determinant. And while you do it, if you have any doubt, just come back and you can watch the steps again, right? All right. And please subscribe to the TeachYaar YouTube channel so that you can get notified. Feel free to share this video with anybody you think will find it useful. And if you found it useful, then please give us a like.